So we're going to those are kind of typically what we see when we work with our customers when we first start to talk about OneFuse and the value that we can provide. But we're going to look at driving vRealize automation configuration. So this is the idea of leveraging configurations to kind of drive your blueprints in a more intelligent fashion. And this is leveraging something called the property toolkit inside of the OneFuse platform. So the first thing we're going to look at is reducing cloud template sprawl, making your blueprints more dynamic by leveraging configurations to drive the outcomes of each of your blueprints and leveraging those to really control configuration drift for your environments. So we're going to come and look at this cloud server template here. And this is essentially very similar to that prior blueprint that we looked at. If we go to look at the inputs, we're seeing the same inputs that we're being asked for. So again, simple, meaningful inputs, something that an end user can understand. You know, what application do you want to deploy? What environment should this go to? What size do you want to drive? What location? What compliance? Based off of these 5 selections in our demo environment, we've come up with 300 or 400 different combinations of outcomes for this single blueprint. And they're all being driven by configuration logic with the OneFuse property toolkit. If we look at this blueprint and come down and look at what our machine element on the canvas looks like, it's quite a bit easier to read than that prior example where we're trying to leverage cloud template expression syntax. And what's going on here is we are essentially taking those 5 inputs that we had just seen in the input selection screen, and we're going to take what the user selects for environment, application size, location, and compliance, and reach out to the OneFuse system to pull in what we call static property sets, which are configuration items that will drive all of the configurations for this particular request. The way that this works is any property on the machine that's prepended with OneFuse_SPS will go out and find the corresponding static property set inside of the OneFuse platform. So what that looks like from the OneFuse side of the house is we come into our OneFuse platform, we can go to these static property sets, and then we can see that all of these static property sets are available inside of OneFuse. We do leverage static property sets. They're really broken down into 2 different functional areas. We have some here towards the top that are prepended with template and some down here that are prepended with PTK. This just helps us to differentiate between the 2 different use cases that we use these for. Template static property sets are leveraged when we're building out integrations. We can get real-time feedback on the output of those integrations when we select one of these templates. But today, what we're focusing on is really these property toolkit static property sets. So I'm going to start by looking at my environment static property set. So we have 3 of them in here. And again, these are configuration information that are going to drive the outcome of our blueprint inside of vRealize automation. If we look at this first one for our development environment, we can come and look and see that this is a JSON formatted example where we are driving these different custom properties in vRealize automation. Maybe we want to influence the name to have a lowercase d in it, or drive it to a folder in vSphere with an uppercase dev, place it onto an IPAM network that has lowercase dev somewhere inside of the name, or drive it to an OU with uppercase dev, place it into a security group that has dev somewhere in its distinguished name. We can also drive, so we're actually driving other OneFuse integrations. We're driving our DNS module and our Active Directory module to call the appropriate policies inside of the OneFuse platform. So all of these configurations all define exactly what it means to be deployed in a development environment for my use case. One of the things that makes the property toolkit extremely powerful is if I have to change maybe the organizational unit that I'm going to drive this to, all I have to do is just maybe extend this out. And now this applies across all of the blueprints that are consuming the static property set. It's a way of making one configuration change that applies globally inside of your environment so that you don't have to go back and address 30, 40, 50 different blueprints. And then maybe you missed one, and now you have one that's not deploying in standardization in a standardized fashion with the rest of your environment. From the environment example, I'm going to jump over to take a look at operating systems. So this is the idea of In vRealize automation, a lot of times we help our customers not drive just the image, but maybe customization specifications if you're leveraging those in your environment as well. So if we look at this CentOS 7 static property set, we have a number of properties that are driven at the root level. So we're going to set a property called Family OS, and we're using this downstream to drive maybe decision-making processes for the family of image that we've deployed. Maybe we're going to change the name to include a lowercase l in there somewhere because it's a Linux server and it helps us to readily identify this inside of our infrastructure. And then we start to see some of these lower level child properties. We have these special properties inside of the property toolkit where maybe you want to drive different integrations differently depending on the system that's calling OneFuse. So if you're migrating from vRA 7 to vRA 8, we can help bridge that gap because vRA 7 calls those things differently. It's clone from and clone spec in vRA 7. But in vRA 8, it's going to be image and or image ref, depending on the kind of component you have on the canvas, and customization specs. So we can drive the same outcomes across platforms that don't traditionally talk. We can even extend that further, maybe into Terraform, so that you can standardize across your Terraform plans what image you're going to standardize on whenever somebody deploys CentOS 7 inside of your environments. And then if we look at the application, one of the things you'll note, we did not see an input for operating system. We didn't allow the user to select an operating system when they deployed. We simply asked them for the application, and then as part of standardizing our application, we're going to drive them to the appropriate operating system under the covers. So if we look at this Apache static property set, we have this property here where, again, it's that special OneFuse _ SPS. What will happen, this will get applied to the resource during provisioning. We actually cycle through the property toolkit 3 times in a row. So the next time it cycles through, it's going to go out and find this static property set to drive my operating system. This allows us to make this static property set or this property toolkit static property set reusable so that we can nest this inside of other static property sets so that we can define CentOS 7 once for our environment. If we need to make any changes to it, we can make it globally in one single place. We can also drive scripting, for example. So when we deploy Apache, we also want to reach out to the OneFuse platform to kick off our scripting module. So this is going to execute a scripting policy that goes out and runs my scripting policy called Linux install Apache. And this just simply reaches out to the guest to install Apache during the provisioning process. Some of those application static property sets, and this is where we would be more dynamic than the base functionality in vRealize automation. We don't necessarily, maybe we deploy Windows and we don't want to run any kind of scripts against it. You'll notice that's just empty. So dynamically adding in the capability to either run scripts or not run scripts, or to run Ansible Tower or not run Ansible Tower. And all of that logic is defined inside of a configuration element rather than directly on the canvas. So we already talked about, minimizing cloud template inputs. So we saw that kind of breaking things down, simple, meaningful inputs. You saw some of the policy-driven decisioning. So we're calling these static property sets in, driving configuration information to standardize the outcome of our blueprints as we're submitting requests. This also helps with reducing custom code. So we've helped a lot of our customers reduce a lot of their custom code, specifically around, some of those dynamic dropdowns, but also event broker subscriptions that may be modifying the outcome of the machine after the fact. We can help with all of those things. We can minimize the amount of cloud template expression syntax required to get you up and running. And that's leveraging configurations and driving your business logic by using simple, easy to understand configurations rather than custom code. So the other way that we help impact vRealize automation is not just for server workloads, but non-server workloads as well. If we come into the vRA 8 demo lab, we have this S3 bucket blueprint, just a sample blueprint. And now in vRA 8, you have all of these different components you can drag and drop onto the canvas. OneFuse can be leveraged to drive configuration information for maybe an S3 bucket or any of these Canvas resources that are available inside of the vRA 8 system. We have these custom resources here that we can drag and drop onto the canvas. In this instance, I have this static property set that I am calling from OneFuse, and the output of that static property set is being leveraged to drive the region and the account selected for my AWS S3 bucket. We're also using a parameter in there that's driving a dynamic name or a custom name that we're generating to guarantee uniqueness, but also something that tells us about this S3 bucket inside of the environment, to drive the name of the S3 bucket as well. So configuration information for maybe somebody selects, I need a development S3 bucket or a test S3 bucket. We can help to target different regions and accounts and standardize all of that leveraging the property toolkit. Again, Damon hit on this earlier. This extends well beyond just vRealize automation. A lot of the customers we work with, we help them standardize configurations in their migration from vRA 7 to vRA 8. So you can consume the property toolkit from both platforms simultaneously. We saw how we can compartmentalize and maybe some properties are specialized for each of these downstream platforms. So vRA 7, vRA 8, the CloudBolt cloud management platform can also consume OneFuse integrations as well as Terraform. Most of the customers I've spoken with over the last 6 months are leveraging at least one traditional cloud management platform, but also we're seeing a lot of infrastructure as code tools leveraged inside of their environments. You may even run into some instances where maybe ServiceNow needs to consume an IP address or a DNS or a DNS record, or go through and actually get a standardized name so that maybe you can build a physical server. As part of our next release here later in the summer, we will have upstream provider support for ServiceNow requests as well. So the ability to standardize cross-platform is extremely powerful with OneFuse. And then finally, the property toolkit is free. So 98% of everything that we've seen here today is completely free with the OneFuse Community Edition. You can go to onefuse.cloudbolt.io to find some technical blog content, some articles that walk you through some common use cases that we help solve with the vRealize automation platform, as well as dig in deeper into some of our other integrations as well.